for finding the sum of an arithmetic series. So let's prove it. So let's write out any series. A1 plus A2 plus A3 plus all the way up to AN. Now let's simplify it into A1 plus, well, we can simplify A2 into the previous term plus a common difference. So it would just be A1 plus a common difference. Now A3 would be also the previous term plus a common difference. So A2 plus D. And all the way up to AN would be AN minus 1 plus D. And now we can simplify it even more. A1 plus A1 plus D. So originally it would be A2 plus D, but what is A2 in this case? Well, A2 is this. So it will just be A1 plus D plus another D, so A1 plus 2 Ds. And this makes sense. There is a difference of D right here, and there's another D right here. So there will be 2 Ds. Now here comes the hard part. What is AN simplified into? Well, first of all, we're going to start with A1 plus, this is the first term right here. There's no D's in it. This is the second term, and there's 1 D in it. And this is the third term, and there's 2 D in it. And this would be the nth term. So 3 to 2 and 2 to 1, they're all minus 1. So there would be n minus 1 D's in it. And now let's just keep what we wrote last. And here we have what we wrote. And now we're going to reverse everything. So reverse A1 plus n minus 1 D to the front plus A1 plus n minus 2D plus all the way to A1. This is reversed of the top function. Now we're going to create corresponding pairs. A1 is going to correspond in position with this. The second term here is going to correspond with this. And we keep going. These terms correspond. Now we add them together. So there's an A1 here, there's an A1 here, so we get 2A1 plus n minus 1 D. And now here, we have an A1 here and an A1 here. So the second term would be 2A1, n minus 2D, and another D. So that would still be n minus 1D. So do we notice any patterns? If we add these ones together, it's also 2A1 plus n minus 1 D. There's definitely a pattern here. Every single pair adds to 2A1 plus n minus 1 D. And how many pairs are there? There will be n pairs since there's n terms in each one. But there's a problem. We can't just write n times 2A1 plus n minus 1D because we originally doubled everything. So we would have to divide everything by half. So in reality, our formula would not be n 2A1 plus n minus 1D, but instead be n over 2. So this is how to find this, another way how to find the sum. Now this formula can be very confusing to prove, but it is very useful when it comes to finding the sum of an arithmetic series, especially when we don't have the value of the nth term, which the previous formula required. So here's a visual of how I proved it. So here we have it first, the typical series, and now we simplify it a little bit into the previous term plus D, and simplify more into the previous term plus n minus 1D. Now we reversed everything, and we keep the reversed ones, and then let's color code them into pairs. And these pairs added together, they all result in 2A1 plus n minus 1D. And then since we doubled it originally, we have to divide the number of pairs n by 2. That's how we got it. And this is the proof for the formula.